Okay, dear students, let us move on to next problem. Question number 5 says write the set builder form of this nothing but rule form. See, to write rule form, you have to observe the property given here, means the elements property. Here you can see it's -1 +1. You have only two numbers. Okay. Now let us go option by option. Option A says A is set of all element x where x is an integer. Coming to integer, don't forget the integers are 0, plus or minus 1, plus or minus 2, plus or minus 3 and moves on. Surely plus and minus 1 which is present here is also present here, but we have extra element. Therefore, this is nowhere equal to the given question. This is nowhere equal to -1 comma 1. So option A ruled out. I wrote A here because the question A is given. Okay. These are the possible answer for the given question. Option B says x is the root of this equation. Let's solve this. X square plus 1 is equal to 0. So if I find the root, x square is equal to transpose, I'll get -1, or from here x is equal to plus or minus root of -1. Root of -1 is not a real number. Don't forget this is actually plus or minus iota, which is not a real number. And we want -1 plus 1. We got plus or minus I. Therefore, option B is also out. Coming to option C, it says x is the root of x square minus 1 is equal to 0. X square minus 1 is equal to 0. Solve for this. X square is equal to 1 or x is equal to plus or minus 1. Yes, we got. Therefore, option C is correct. Okay, this is correct. Coming to option D, let us check that also. X is a real number. Real number R. Real number R contains both rational as well as irrational. And one more point I want to highlight. I want you to take as a note that every interval, we discussed interval concept. So let me take this marker. Every interval is a subset of R. See carefully here, one point I want to highlight here. See, whatever the interval we have discussed, let it be open or closed, whatever. Okay, all the intervals, let it close. When I say close, I'm talking about all the remaining three also, is always a subset of real number. And real number is an open interval minus infinity to plus infinity. Both plus and minus infinity does not belong to real number, as real number is open interval minus infinity to plus infinity. So every interval, let it be closed, open, okay, all the four is subset of real numbers, okay, R, which is a union of rational and irrational. Okay, so option C is correct, even option D is out. Now moving on to question number 6. The set T. See, we know T stands for set of irrational number, but now they have given some other. The set T is given by this. Then which of the following is true? What is set T? It is set of all real numbers such that x minus 3 is equal to x plus 4 the whole square, where x is less than 2. So under this condition, I have to find the element of the set T. Then they are asking which of these would be true about the set T. Option A, T is empty set. Option B, T is singleton set. Option C, x equal to 3 is a member of T. Option D, x equal to -4 is a member of T. For that solution, very simple problem it is. Sir, how come? See, careful observation is required. See, since x is less than 2, if I talk about less than 2, no? For example, x is equal to 1 if I talk about. 1 minus 3 will be -2. Nothing but left hand side is surely negative. Left hand side is what? Surely negative number. Negative number. Whereas right hand side is having square here. So even the base can be negative, positive or 0. The right hand side will be always greater than or equal to 0. Nothing but non-negative. Non-negative. It cannot be negative. But here it is always negative. How come a negative be equal to positive or non-negative? I repeat, how come a negative can be equal to non-negative? Therefore, it will be an empty set. Option A is correct. Without solving this, we analyzed it. Okay. Let us make a note of. Okay. Dear students, now let us complete question number 7. Recalling, no? Yeah. Which of the following is an empty set? Don't forget definition of empty set, not even a single element should be present. Now the first option A says set of all these, set A is set of all the element x such that x is a natural number satisfying a linear equation 2x plus 5 is equal to 6. Let us take option A here. So I have to find such a natural number which is satisfying this equation. Solve this. So sum of two terms I can transpose, so I'll get 2x is equal to 6 minus 5, or 2x is equal to 1, 6 minus 5 is 1, cross multiply 2 or divide by 2, we can say x is equal to half. Half is not a natural number. Because of this reason itself, I spoke about number system, natural number, whole number, integer, then rational, irrational, real number, as well as intervals. So yeah, this has a solution, that is half, but half is not a natural number. Therefore option A will be an empty set. This will be an empty set. That's what they asked, so option is correct. So even though we have got the answer, let us move on to the next set of options. Let us suppose this was the exam. In exam, this question came, and as soon as I came to know option A is correct, surely I will not go for the remaining option until unless in the remaining option something like none of this, no, option A and C, for example, if they could have said, then I'll check C also. Okay, who knows, C may also be correct. But in this, as such, there is nothing. But I just want to have a clarity, still more clarity for you. Now see, coming to option B, they are saying set of B set of all the element x such that x is natural number and it is lying between 1 to 2, and equality is given for 2. Nothing but 2 is taken, 1 is not taken. This is completely our interval concept. 1 is not taken, 2 is taken, and in interval everything should come. And here, close. But here, be careful. As soon as x is a natural number, all these number in between gone. Okay, only x at 2 is shaded, x equal to 1 is not shaded. So this will be set 2, and 2 is, now since I have got 2 here, now it's a singleton set, it's not an empty set. Option B not correct. Coming to option C, it's an even prime number. Which is that number which is prime also even? Define prime number, a number greater than 1 which is divisible by 1 and itself. So it's a, I repeat, prime number definition is a number greater than 1 divisible by 1 and itself is known as prime number. Okay, so the prime numbers will be 2, 3, 5, 7. 9 is not a prime number. 11, 9 is only an odd number because 9 is divisible by 3 also. That is nothing but it is divisible by other than 1 and itself, that is 3. Now here it should be even also. The only number which is prime and even is 2. Okay, 2 against a singleton set, out. And x is set of all rational number 1 to 2. Don't forget, between two rational numbers we have infinitely many rational numbers. Similarly, between two irrational numbers we have many irrational numbers. Not only that, let us have as a note for you, as a note, between any two rational numbers, that is Q, we have infinitely many rational and irrational numbers. I hope this is clear. Rational and irrational numbers. For example, if I talk about this number, let's say 2 and 3, I can have, and here is okay, 1. Root 2, for example, will be somewhere here, which is approximately 1.4. Like this, we can root 3 is 1.7, somewhere here, root 3. So we will have infinitely many rational numbers as such. Okay, pi is approximately 3.14, somewhere here, between let us suppose 3 and 4 is somewhere here. Okay, 3.14, somewhere pi. And similarly, between two rational numbers, so similarly between two irrational numbers in the textbook you have taken as T in NCERT, we have many rational as well as irrational number, rational as well as irrational number. Kindly make a note of this. Now, before I take question number 8, I want to talk about different ways of interpreting, I can say, intervals with respect to modulus. First, make a note of this. Before I just comment, I forgot to comment about D. X is a rational number between 1 and 2. Yeah, we have infinite many rational numbers, so option D is also out because we want only empty set. Option D is the only correct one. Okay. Now, let us move on to the intervals, not the two which we discussed with respect to modulus. So, see, first understand this modulus. In detail, we'll discuss the graph all in chapter relations and functions. Now, only with respect to the inequality because modulus is involved here. So, I thought we'll discuss. See, if I've got mod of 2, it is 2 only. Mod of minus 2, it is plus 2. Mod of 0 is 0. In short, mod of any number is non-negative. Nothing but either greater than 0 or equal to 0. Either positive or equal to 0. Whenever I say non-negative, what's the meaning of that? If I plot a number line, see carefully. This side, right to 0, we have positive numbers. Left to 0, we have negative real numbers. Here you can have half also, 0.75, all those. Now, as soon as I take mod, what happens is mod will convert all the negative number to positive. So, this entire negative number till here will just jump here. So, it will be, let me take some other color. Here, the entire negative number, mod of 0 is 0. So, it is this. And this entire negative number will jump to this. Okay. Now, I just want to talk with respect to the interval as well. Okay. Now, just see carefully the first point. If I talk about mod of x less than a, so again I will take 0 here, a is somewhere here, and minus a is somewhere here. As soon as I talk about mod of x less than a, strictly less than a, what's going to happen? Mod is going to convert negative to positive. So whichever number is it, let us be still more specific. So to make you understand this, if I first take a number, let's suppose some 3. So I've got here minus 3 and here plus 3. So mod of any number between 0 to 3 will be 0 to 3. So nothing but this is the answer between 0 to 3. But if I take any number here and if I take the mod of that, mod of minus 2 will be plus 2. All this number will jump here. All this negative number will jump here when I take a what? Mod. So the meaning of this is minus 3 less than x less than 3. So all this, as soon as I take mod, will confine to this, nothing but whenever you have got mod of x less than 3, the meaning of this is all the number from minus 3 to 0, including 0 and 0 to 3, but both minus 3 plus 3 not included because strictly less than. You can just think like this. Here one pole is there. What is it? Pole is there, and we have tied to a horse. So horse we have tied such a way that length is 3. From here also 3, from here also 3. Now the horse can can go till here. It can't go beyond 3. Okay, and since I can strictly less than, so here open bar. Okay. Similarly, the horse can come back and can go only till here, again open bar. It cannot go beyond. Okay. So this is the first one. Second, okay, now in general, how I will write mod of x less than a means minus a is less than x less than a. Now for the same thing, okay, this to be understood. That's why I give an example. If I have given you mod of x greater than, okay, first let us complete with less itself, less or equal to 3. Now what has happened is I've just included 3 and minus 3 now. So taking this all here and then close. This all numbers will jump here. Okay. So this will contain all these numbers. So as soon I'm talking about this entire thing is also covered. Correct? No, this also is covered. Okay. And in short writing like this. This also is covered. Okay. Mod is, as soon as I talk about mod, whichever number is there, when I take in the mod, I'll get less than 3 only. So here this will be what? Minus 3 less or equal to x less or equal to 3. Only equality is added because equality is there here. And if I talk with respect to this number line, this is 0 here. So all this will be here. And again, all this will also cover. The entire thing is covered. Entire thing is covered. So we are going to have mod of x less or equal to a is minus a less or equal to x less or equal to a. You should know this. It should be in your fingertips. Okay. Similarly, third point. As soon as I say mod of x greater than 3, what's the meaning? See, plus 3 is here, minus 3 is here, and 0 is here. So this is plus infinity and this side is minus infinity. I said first without here mod number more than 3, positive number more than 3 will be not lying here. It will be all the numbers, okay, strictly greater than I have given. So open ball here and then tuck all this number. Even if I take the mod of this number, all this if I jump, it will jump here only. Correct now? So it is what? 3 to infinity. So it is going to cover mod of x greater than 3 is going to cover all the numbers x lying from minus infinity to minus 3 union 3 to infinity. Then similarly mod of x greater than a. As I'm saying mod of x greater than a, mod is there, so only they should be got positive. And now in place of a means 3, in place of a we have 3. Just replace the x belongs to minus infinity comma minus a open interval union a to infinity. This is a minded. That is problem and it's completed. Let us have the other two note. See, as and how we will proceed, some new concept will be coming and I'll be discussing as well as those new concepts as well. So now one more thing, point number 4, same on this. If I just say mod of x is greater than or equal to 3, okay. So and one more thing, no, whether I like this or like this, both are same. Similarly here also both are same. And one more thing, the other way of writing this will be x belongs to open interval minus a to plus a, interval concept. This also is same as x belongs to close interval a to a, means minus a to a. I've already written the interval form here. Otherwise, write a bit more clearly. Minus a comma a. See, we should know all the different forms. All the different forms we should know. Okay. Now coming to this. Now what's the difference of this? Here equality is not there. Here equality is not there, and here equality is there. So if I talk about number line, hope so recording. Yes. Minus infinity to plus infinity. And then here 3 and here minus 3, then we have midpoint 0. I want all the numbers beyond 3 or equal to nothing but this shade and all this, and here again shade, and here all the left all those numbers less than or equal to minus 3. After I take mod, all will jump here. So this will be also x belongs to minus infinity comma minus 3 close union close interval 3 to infinity. Now next is the 5th point. Let us suppose that a, okay, I have got two numbers. A is more than b and b is positive. All the three are positive, means all a and b are positive, I mean to say. And it is such a way that we have got a expression b square is less than x square is less than a square. Okay, when a is more than b, it also means that b is less than a. Now if I take root on both the sides, don't forget square root of x square is mod x. Okay, root of x square is not x, root of x square is mod x. Now if I take root on both the sides, then we are going to have all the real numbers. If I take root on both the sides, we are going to have minus p. X will belong to. So we have got this. First, let us plot on the number line. See, 0 is here. B is less than a, so B should be somewhere here. This is 0 minded. There is a B here, and there is a here. When I talk about the negative side of this real number, so first see this carefully. If this is 1, this is 2. Here what should happen? First minus 1 should come and then minus 2 should come. So it means here I should have first here minus, first I should have minus here. I use the word first, it's always left to right. So minus a to minus b. I have taken b to be less than a. So x will belong to this number, because as soon as I take mod, all this will jump to this region. Let's change the color. This region it will be. And then to closed, because I've given, okay, I'll take a close here. So given open, you know the same thing. Wherever equality is there, close. Wherever equal is not there, it is open. So x will belong to close interval minus a comma b union close interval b comma a. As soon as suppose I give you her open, wherever you have got b and minus b, that is what here, and you should give open. As soon as I give here open and here close, only for minus here and plus here you should give open. So given both for open, everywhere we got open interval. So these are the 5 different ways of writing the intervals under modulus. And after having discussed solely for other set of chapters, it will be helpful. One thing you please understand, chapter 6 is a very basic chapter for the rest of our mathematics. Don't ignore it. Now moving on to the next. Solution for question number 8. Recording? Yeah. Which of the following is a null set? They are asking about null set. So coming to the first option A, I want a set of all the numbers x like that. Mod of x is less than 2 and x is a natural number. Mod of x is less than 1. So again, this only I just defined all this. So in place of 3 we have 1. So if I take the without the mod, it is only this, nothing but exclude both minus 1 and plus 1, which is a number present only 0. 0 is not a natural number, therefore option A is null set. We got the answer because there are no natural number obeying this. Okay. Now coming to option B. Anyway, we got the answer. Let us go for the remaining option to enhance our knowledge. That's very important. Set of all numbers x, mod of x is equal to 5, where x is a integer. So mod of x is equal to 5. In the question they said only they want what? X. So if I remove the mod, I'll get x is equal to plus or minus 5. So I have got 2 elements here. Therefore, this is not a null set. So option B is out. They want only null set. Let us suppose I could have taken x is belonging to irrational number. Then option B will become null set. Now coming to option C, x set of all number x such that x square equal to 1 and x is an integer. So x square is equal to 1. Solve for x. X is equal to plus or minus 1. Yeah, both are integer. This is also an integer. This is not a null set. Option C is out. Now coming to option D, they are saying set of all the numbers x such that x square plus 2x plus 1 is equal to 0. X is any real number. So I want the root of this. No need to solve this. No need to solve. They said root is a real number. Just find the discriminant. If discriminant is greater than or equal to 0, roots are real. If discriminant is less than 0, roots are imaginary. That's it. So if I compare with ax square plus bx plus c is equal to 0, x square multiple is here, here it is 1, so a is equal to 1. B, x multiple is b and x multiple is 2, so b is equal to 2 and c is also 1. So here delta is equal to b square minus 4ac is equal to b is 2 minus 4 into a and c both are 1. So 2 square is 4 minus 4, answer is 0. Delta is equal to 0. This implies roots are real and equal. Therefore, option D is also not a null set. I hope you remember this logic. Let us recall. Who knows, in one or the other problem to be very useful. If you talk about the discriminant of a quadratic equation, that is delta is equal to b square minus 4ac. I think space is not sufficient. I'll discuss it here. First, kindly make a note. Okay. Before we proceed, no, I think I just forgot to give the general way of this. So the general way of this let us mention here. Sorry for that. Mod of x greater than or equal to a. Wherever t is mentioned by a there. So this will be x belongs to minus infinity minus a close union close interval a to infinity. Okay, this is a minded. Fine. Now coming to the discriminant, what I want to discuss here, I am going to discuss. So coming to a quadratic equation, that is ax square plus bx plus c is equal to 0, where a is not equal to 0. If you talk about the discriminant, that is b square minus 4ac. Now we have got some of the things to be decided. If delta is equal to 0, what? If delta is greater than 0, what? And if delta is less than 0, what? If delta is equal to 0, roots are real and equal. Delta is greater than 0, here roots are real and distinct. Distinct means what? Different. Distinct means different. Okay. Now if delta is less than 0, what's the meaning? Roots are not real. When I say roots are not real, that is roots are complex. So let you have all this information. Okay, fine. Kindly make a note. We'll move on to the next problem. Okay, dear students, now let us move on to the next problems. Question number 9. The set A is containing set of all the element x, which is a real number, and it should be a root of this. Now see here, they have used one word and, nothing but I want that x value which is going to satisfy this quadratic x square equal to 7 and this linear 2x is equal to 6. At a time both should happen, and they're asking the option, is it a null set, singleton set, infinite set? None of this. Surely it will not be infinite because degree 2 will have only 2 roots, quadratic, and since degree is 1 here, linear, so only 1 root. So infinite is out. Okay, now let's see among the three. X square is equal to 16 and 2x is equal to 6. If I take the root here, x is equal to plus or minus root of 16, or x is equal to plus or minus 4. I'll take this as equation number 1. Okay. Now, and here, 2 1s are 2 3s are, x is equal to 3. Now, take common between and they have used, so 1 intersection 2. This contains the element plus 4 minus 4, and this contains 3. Do we have any common? No, it is null set. So option A is correct. Option R is correct. I hope this is clear. Moving on to next. Which of the following is a singleton set? Singleton set. Now let's go option by option. See, x is a natural number. Mod x is there. If I remove the mod x, I'll get x is equal to plus or minus 5. But be careful, here we have two solutions, x equal to 5, it is a natural number. One more is x is equal to minus 5, it's not a natural number. Singleton set, option A is correct. This answer is only plus 5. Okay, let us check the remaining option also. Here, one option is both A and B. Oh, check this. This option B right here. So set of all the element x, set that mod of x is equal to 6. So mod of x is equal to 6. X is a natural number they have said. Remove the mod, x is equal to plus 6. Yeah, natural number. Whereas x is equal to minus 6 is not a natural number. Therefore, for this only x equal to 6. Yeah, it is again a singleton set. So it is both option A and B. So option D is correct. Whereas, let's write this as option. Yeah, okay. Whereas, if I see option C here, set of all numbers x such that x square equal to 7, and x is a natural number, x square is equal to 7. X is equal to plus or minus root 7. Root 7 is an irrational number. And here they said rational, so it doesn't belong to a rational number. Therefore, the set C will have empty set. But they want singleton set. Singleton set means number of elements should be 1. Here we have 0. Number of elements are 0. Number of elements are 0 here. Whereas in option A and option D, here we had 5, only one element, singleton. And here also we had only one element, 6, singleton set. Okay, I hope this is clear. Moving on to the next question, which of the following is a finite set? Finite means we should have definite number of elements. Set of natural numbers. Coming to option A, we know natural numbers are n is equal to 1, counting number 1, 2, 3 moves on. This is not a finite set. Option A out. Option B, set of rational numbers. This is also not a finite, we discussed already. Set of days or in a week. In a day, we have only 7 days. Yeah, we can have a definite number. Therefore, option C is a finite set. Set of concentric circles. Recall what is concentric circle. Any circle having same center but different radii. So, if I talk about this is a center. So, I can have first circle with same center. Again, I can have one more circle with same center. Again, one more. Okay, like this I can draw. Not only that. Between these two circles, I can have one more circle which is having the same center as C. Center is C. Again here also center is what? C. Okay, again here also I can have like this, I can have infinitely many. So this will be an example for infinite set. So option D is also out. So only option C is correct. Kindly make a note. Now let us proceed with the next question. Question says, which of the following is a finite set? Nothing but definite number of element we should have. Set A is set of rational numbers in closed interval A 0, 1. Option B, set of irrational numbers in closed interval 0, 1. Option C says set of natural numbers in closed interval 0, 1. Then none of this. See here. First commenting on option A and B. Recall, now here 0 and 1 are two rational numbers. So we know that between two rational as well as irrational numbers, we have infinitely many rational numbers, many rational as well as irrational numbers. Don't forget this point. This will help you a lot for this type of question. So if I have got two rational number or irrational number, between them I'll have infinitely rational as well as irrational. Similarly, between rational and irrational number also we'll have infinitely rational as well as irrational numbers. Okay. So these two will have infinitely many. So these two will have infinitely many elements. Infinitely many elements. So because of this I can say that option A and option B will have many elements, but they are what? Finite. This implies both option A and B are infinite set. It's infinite set. Option C, set of natural numbers in this. Yeah, which is a natural number? Counting them starting from 1, 2, 3 and one close interval is taken. So for option C, the only answer is element containing 1. Yeah, it's a singleton set and it is a finite. So option C is correct. So only option C is correct for this. Okay. Now moving on to the next problem. Question number 13. Let S be set of all element x such that x is a positive multiple of 5 less than 100 and P is set of all element x such that x is a prime number less than 30. Then we have to find number of element in S plus number of element in P is. So they're asking, is it a finite set, singleton set, infinite set or null set? See, for this problem, no, there is no need for you to find separate and then give a count. See, addition is it. Sum of two finite quantities is again a finite. And sum of infinite and finite will be again infinite. And sum of two infinite will be infinite. So just see whether S and P are finite or infinite. S is set of all what positive multiple of 5. If they could have said positive multiple of 5 is infinite, but they said less than 100. So number of element in S is what? Finite. Next, P is set of all prime numbers less than 30. If they could have just said prime number, we could have infinite, but here it is multiple less than 30. So number of element in P is also what? Finite. And now they want sum of these two. So that's what I said, that if at all we have got sum of two quantities and since both are finite, so finite plus finite is what? Finite. So sir, singleton is also there. Just see. As soon as we see positive multiple of 5, it's more 5, 10, 15. Okay, we have got more than one element in this. So sure, it's not a singleton set. It's only a finite, not of the remaining. Option A is correct. Moving on to next. Option A this is. Moving on to next. Before I go for this, since P of A is there, let us recall one concept. What? Power set. What is power set? It is collection of all the subsets. It is a set of collection of all the subsets of a given set A and denoted by P of A. P of A. If I'm talking about a set A, power set of A is P of A. If I'm talking about set B, power set of this is what? P of B, right? So since already A is taken here, I'll just take as B, for example, to make it clear, B. And suppose B elements are 1 and 2. Now find all the subset. Already we discussed a formula to find number of subset. It is 2 to the power of number of element in the set given to you. Here it is B. So 2 elements are there. So number of subset will be 2 to the power of number of element in B. So how many elements are there? 2. So 2 power 2 will be 4. So which are the subsets now? Which are the subsets now? The subsets of B are subsets of B are empty set, then from here singleton set 1, then single set B means 2, I mean to say, and then element containing both 1 and 2. Okay, and this, see, without flower bracket these are subset, but as soon I am giving, okay, subset I wrote. Now what is power set? Okay, let's write power set. Now the power set of B will be collection of all the subsets. So write down them in the form of what? As soon I write them within a flower bracket, it is what? Now it's a set, and it's a set of all the subsets. That's what we call power set. Okay. Now they're asking if A is a empty set, then power set A is null set, singleton set, finite set, infinite set. Very simple we can get. Since A contains no element, this is same as this one, no? So number of element in A is how many? 0. So number of element in power set is same as, formula is same as number of subset in the given set. So to the power of number of element in A, 2 power 0 is 1. There is one element in the power set. Which is that element? The set A itself, nothing but empty set. So we have only one element. Therefore, it's a singleton set. Option W is correct. I hope this is clear. I repeat again. A is empty. So subset of that is what? The set itself. For every set, empty set is a subset. And for every set, the set is also subset of itself. So since A is empty, so the set is itself. Only one element is in power set. Singleton set it is. Okay, fine. Kindly make a note. And here, what are the elements of power set of A? Now, each of these are element. Fine. Flower bracket 1, flower bracket 2, and flower bracket 1, 2 are elements. Kindly make a note. Moving on to next question number 15, dear students. If A is equal to the set containing the element 1, 2, element is 3, 4 and 5, then which of the following is false? Okay, so be careful to go for this now. First, write down elements of the set A are, which are the element 1, then 2, then flower bracket 3, 4, and then 5. Right? Now we have discussed relationship between, one symbol is used for relationship between element and set, belongs to, does not belong to, and for subset is a relationship between two sets. Now you just see. They ask which of the following is false. 1. Yeah, 1 is an element of A, so belongs to. This is true. Because this is going to give a relationship between element and a set. Yeah, 1 is present in set A, as you can see here. Therefore, it is true. Then flower bracket 3, 4, subset of A. Just see this. This is an element. Since an element, it should be belongs to. If at all it should be a subset, then this should be actually flower bracket 3, 4. Make it set by giving a flower bracket, then it's a subset of A. This is true, but whatever they have given here is false. Therefore, option B is correct. If you want to check the other, now this is correct. Now this is the element, therefore belongs to should be used, so true. 5 is an element, yes, true. They want the incorrect one, the one which is false. So option B is a false one. Okay. Now moving on to the next question. Which of the following sets are not equal? And they have given the option. Now first option, let us go option by option. First option says set of all element x, x is an integer, x square is less or equal to 4. Because of this itself I discussed that 5 intervals, okay, with the modulus. See this, x square less or equal to 4. If I take root on both the sides, root of x square is mod x, less or equal to root of 4 is 2. So integers less or equal to 2, come on, which are the integers? So here plus 2 and here minus 2. The integers are, here it will be minus 1, then 0 and 1. So minus 2, minus 1, 0, 1, 2. These are the elements which will have set A. So I write as set A here. Both are right. So just see here, set B. Set B is all the integers having, which is the root of x square minus 4 equal to 0. Solve this. X square is equal to 4 or x is equal to plus or minus 2. Therefore, set B, this is for set B, this is for set A, we have solved. Set B is containing the only two elements, minus 2 and plus 2. So, see, when do we say two sets are equal? All the elements should be the same. Set A is this, set B is this. Very clearly, set A contains 5 elements, set B contains minus 2 plus 2. Actually, set B is a subset of set A. So A and B are not equal. They want equal set. There is a square here. Mind it. Visible now? Okay. So A and B are not equal, and they ask which of the following are not equal. So option A is unequal set. So option A is correct. Let us have a clarity for the remaining set of options. In examination, after you got to go for the next question. You want the remaining. Here, I just want to give the clarity because class going on. You should understand each and everything here. So set B, okay, option B has got set C containing minus 3 plus 3, and coming to set D, it is set of all integers having this roots satisfying this equation. So if I transpose this, I get x square is equal to 9, x is equal to plus or minus 3. Yeah, therefore set D contains 3 comma minus 3, and here also it is the same. So option B, when I talk about set C is equal to set D. Coming to option C, the elements are 2, 4, 6, 7, and the set F elements are 7, 4, 6, 2. Just see, elements are same. 2 is there here, 4 is there here, 6 and 7, 6 and 7. Yes, even option C, set E is same as set F. Then D, G is set of letters in the word loyal. G is set of all letters in the word alloy. Let's write that. Coming to option D, G, set of all the letters of the word loyal. Loyal element should not be repeated. So first L, then followed by O, then Y, then A, and then L. L is there already. Okay. And set H is set of the set of letter in the word alloy. So H, alloy, right, one by one. A, then L is there twice, right, only once. Then O and Y, O and then Y. Now just check, have they got same elements? A, L, L, O, Y, Y. Yes, G is equal to H. They want which one? Unequal. Unequal is only A not equal to B. That is there in option A. Okay. And here, okay, they were not equal, no. So only A, only A is correct. C, I maybe might have ticked in just saying, no, E is equal to F, correct. They want not equal. Okay. So only not equal set we want. Now this question number 17 is about Venn diagram. They are asking if A and B, A containing 2, 4, 6 and B containing 1, 2, 3, 4 are the subsets of the universal set U 1 to 10. So 1 to 10, natural number 1 to 10 taken by U is known as, it is taken as universal set. Then the Venn diagram, correct Venn diagram is, see, first for this type of question, first always find common. What is A intersection B? What is the common element? 2, then 4. 2, 4 is common. Remaining there is nothing. 2, 4 is common, and in the diagram, this part is common. 2, 4, 2, 4, and here is only 4. Here there is nothing common. So straight away, option C and option D are ruled out because common contains 2, 4. It is not here. It is only for, and here it is saying that it is a disjoint set. It's not a no, it is not a disjoint. It's a non-disjoint because intersection is not empty. Now the competition is between only option A and option B. Very simple now. See, 2 and 4 gone. Now see, this is only A part. Only A contains 6. Yeah, 6 here. Yeah, so 6, fine. Then only B should contain 1 and 3. 1 and 3. So this set A, B is same. Now see the complement of A union B, the outer. The outer should be what? See, 2, 4, 6. 2 is taken, 4 is taken, 6 is taken from universal set. And 1, 2, 3, 4. So 1, 2, 3, 4. So now A union B complement, nothing but the region outside this 2 circle and within this rectangle box should contain 7, 8, 9, 10 and 5. Just see which contains, yeah, here we can't see 10 here. So here 7, yeah, 7, 8, 9, 10. 7, 8, 9, 10 and 5. So everything is contained in this. So option blue is correct. I hope this is clear. Kindly make a note. So let's solve here. Set A intersection B is common element. What is the common element? Check it out. 6 is there, 12 is there. That's it. 6 and 12 is common. Next is B intersection C. Common between B and C. What is it? 5, 10, 15. Okay, 15 is common. That's it. What is common in C and A? C intersection A. C. 20, 20. That's it. What is common between A, B and C? A intersection B is 6, 12. Intersection C. C is 5, 10, 15, 20. 5, 10, 15 and 20. Is nothing common? It's a disjoint. Okay, now let us draw the Venn diagram for this. This is the universal set. Set B here. Set A is here. And set C. Now common most. Can you see blue, black and red? Blue, black and red, common most. Nothing is common, so I have to leave this region empty. Don't forget this region is what? This region is what? It is C intersection. Okay, A intersection B intersection C. A intersection B intersection C. Then recall, what is this region? This region is containing blue and black, nothing but set A and set B. So this region is A intersection B. Then this region, red and black, this region is B intersection C. Whereas this region contains red and blue, nothing but A and C, nothing but A intersection C. Okay. So having all these ideas, let us proceed one by one. Let us mention them. So common is nothing. So I left this empty. Here A intersection C common is 20. Then this one is B intersection C, that is 15. Then A intersection B is 6 and 12. Now here only A. Come to A. Other than 6, 12, 20. Don't write 6, 12, 20. Other than this remaining you can write. That is 2, 4, 8. Okay. 2, 4, 8. Then 6, 12, 20. Yes, the remaining are there. If I take the entire set A, yes, I get the entire set A. Next, come to B. Coming to B, 6 to 12, 15 should not be 10. 6, 12, 15 should not be 10. This side. This is what? Only B. So only B elements are 3, 9. So you can see now 3, 6, 12, 9, 15. 3, 6, 12, 9, 15. Yes. Now C, this part, only C. So in that I should remove 15 and 20. Remove 15 and 20, we get 5 and 10. Yes. All done. Now compare among this which is satisfying, that is option blue. Whereas here if you see 12 is in here, but it is common. So option A is out, and here if you compare why it is wrong, yeah, 15 is common between B and C, it is not given as such. So option Bablu is correct. I hope this is clear. Kindly make a note of this. Moving on to next question. Question number 19 says, if A is set of all the element x such that x equal to 2n plus 1 when n is integer. See, 2n is even number provided n is integer. 2n plus 1 is what? Odd number. So it completely depends on this n. If n is natural number or integer, only then this entire thing is what? Odd numbers. 2n plus 1 or 2n minus 1. You can see, put n is equal to 1. 2 ones are 2, 2 plus 1, 3. Put n is equal to 0. 2 into 0, 0. 0 plus 1, 1. So 1, 3, both are odd number. Similarly, B set of all element x such that x is a even multiple of 2 when n is an integer. So all this will be what? Even numbers. Now they are asking what is A union B. A union B. See, A is what? All odd numbers. That is plus or minus 1, plus or minus 3, plus or minus 5. Okay, I'll let next line. Nothing wrong. Yeah, plus or minus 1, plus or minus 3, plus or minus 5 moves on. Union. What is B? All the even numbers, which are those 0, plus or minus 2, plus or minus 4, and moves on. So union means adding common and common together. So I will get this to be what? 0. Then plus or minus 1, then plus or minus 2, then plus or minus 3, then plus or minus 4, and so on. This is what? Integer. Option Bablu is correct. One note for this problem, if I ask, problem completed, one note from my end. What if the question is A intersection B? Do we have anything common? Do we don't have anything common? Set of odd numbers are different and set of even numbers are different. Set of even numbers are those which are divisible by 2, and odd numbers are those which are not divisible by 2. Therefore, the intersection should be empty set. Okay. Next, question number 20. If A, B, C, and D is even, find A union B union D. I just took a Venn diagram where I found A intersection B intersection C. I thought I'll also once take one problem now on this. See, in this there is no what set C, so set C will not be used. So A union B union D. A union B, if I found here 1, 2, writing common and common together. So 1, 2, 3, 4. 3, 4 is common. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Union D. D is here. 7, 8, 9, 10. So the answer will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the natural number 1 to 10. 1 to 10 is in option C. So option Chalu is correct. Let us check once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, correct. Now come to this question. If A and B, so A is a set X containing a such that it's a solution of quadratic equation, same for B. So I have to first find the roots of this. So let us take this one. X square minus 7x plus 12 is equal to 0. X square multiples 1. 1 into 12 is 12. Factorize 2 6 are 12. Then 2 3s are 6. 2 2s are 4. 4 plus 3 is 7. So minus 4 minus 3 will be minus 7. So it will be x square minus 4x minus 3x plus 12 is equal to 0. So what is common here? Check it out. What is common here? Here common is x. So I'll get x times of x minus 4. Here common is minus 3. How, sir? Make it minus and 3 and 12. What's common? 3. So minus to minus plus 3 and minus 3. Minus 3 is taken common out. So x minus c. Minus is taken out, so remains what? Plus 1x. Okay. Minus into plus is minus. So 12 divided by 3 will be 4 is equal to 0. Common is what? X minus 4. Then remaining is x minus 3. So if I equate to 0, I'll get either x minus 4 is equal to 0 or x minus 3 is equal to 0. So x is equal to 4 or x is equal to 3. X is equal to 4 or x is equal to 3 is the element of set A. So set A elements are 3, 4. Now let us go for this. Let us do it here. X square minus 3x plus 12 is equal to 0. We have to find the roots. 1 into 12 is 12. Okay. Oh, 2 here. 1 into 2 is 2. Then 2 ones are 2. Minus 2 minus 1 will be minus 3. Fine. So x square minus x minus 2x plus 2 is equal to 0. Common is here x. So remaining is x minus 1. Correct? Then here minus 2 is common. So minus 1 is plus, 2 is out. So minus 1 is plus. Then x minus 2 plus is minus. 2 is out. So 1 here. So we are going to have x minus 1 here. Then here x minus 2. Product of two term is equal to 0. This implies either this should be 0 or this should be 0. If I equate them, so I'll be getting x minus 1 is equal to 0 or x minus 2 is equal to 0, x equal to 1 or x equal to 2. These are the roots. So set B, this we have to find. So set B is 1 comma 2. Now find the union A union B. Writing common uncommon together, it will be 1 2 3 4. 1 2 3 4. This is the set A union B. 1 2 3 4 is then option blue. B is correct. Option B is correct. First, kindly make a note of this. For the question number 22, I need the space. I hope this is clear. Yes, fine, dear students. Let us move on to first question number 22. Question number 22 is completely on intervals. Okay, this is also intervals. Okay, let's take both. Question number 22 says if A is set of all real numbers x, 0 is less than x less than 2, open interval it is, and B is set of all number x such that 1 is less than x less or equal to 3, then in the option they are asking union. So coming to the solution, what is A? Set A, if I take on number line to be very clear, it is the number between 0 to 2, but it is not containing 0 and 2, it is all the numbers in between them. Other color. So my set A, open this to, and here all these numbers are taken. Next, coming to set B, it is set B is set of all the element from 1 to 3, 1 is not taken, but 3 is taken. 3 is taken, but 1 is not taken. Till here. Now they are asking union. Fine. See, union means writing common uncommon together. If I plot all these 3 on the number line, 1, then 2, up to 3. 1 to 3. See here. 0 is also there. Fine, 0 is here. So 0 to 2. 0 to 2, okay. But open ball at 0 and 2. So this is 0 to 2. Then 1 to 3. Yeah, 1 here, and then 3 is taken. So what is union? Writing common and common together. So it starts from 0, ends at 3. 2 is not taken by the set A, but it is taken by set B. So the answer will be open interval 0 and close interval 3. I repeat, 0. See, 0 is not taken by A nor by B. It starts, B starts from 1 and ends at 3. 3 is taken. In B, 1 is not taken, but in A, 1 is taken. And in B, 2 is taken, and in A, 2 is not taken. In A, 2 is not taken, but B, 2 is taken. So it's all the numbers between 0 to 3. 3 is taken, and 0 is not taken, as you can see here. So it is open ball. So the answer for this other way of writing is what? It is set of all the element in A union B such that 0 is less than x less or equal to 3. Which option it is? Oh, here, okay, option B is correct. Be careful in option A, less or equal to Z. 0 is not taken. We have to be extra careful. Okay, we have to be extra careful. Not only that, our concept should be crystal clear. If I have a doubt, for less than, is it open ball or closed ball? Gone case. Now one question, what could be A intersection B? This is from my end, okay, as a note. Problem completed already, okay. The curiosity, what about A intersection B? A intersection B. Let us do one thing for this problem, no? We'll find A intersection B, A minus B, then B minus A. A intersection B, see the diagram. It's common element. Common is what? 1 to 2. 1 is taken by A but not taken by B. So it is open interval 1 and all the elements are taken between 1 and 2. 2 is not taken by A and taken by B. 2 is not taken by A but taken by B. So again it is open. This is all what set of all number 6 such that 1 is less than x less than 2. Okay. Let us suppose they are asking what is A minus B. Nothing but all the elements containing only in A. Set A only is this, but 1 is taken by both, so I should remove 1. So it will be open interval 0 comma 1. Nothing but set of all real number x. Okay, real number x, here also x is a real number, such that 0 is less than x less than 1. Check it out. Is it correct? 0 to 1. Yeah, 1 is taken for a while. 0 to 1, no. So it should be only in A. B is not containing 1. B is not containing 1. So 1 is also taken by A. Equality will come. I hope this is clear. A minus B means only elements contained in A. First set A. So in first set A, the element from here till here is taken, including 1. 1 is not taken by B. Okay. Similarly, B minus A. See what happens in B minus A? All the element contained in B only. So B is this. It is from 2 to 3. 2 is not contained in A. It is containing 2 is contained in B as well as 3. So it is set of all the real numbers such that 2 is less or equal to x less or equal to 3, which is same as close interval 2 comma 3. Okay. I hope this is clear. Kindly make a note. 2 comma 3 fine. 0 open 1 2 yes, all done. Now first make a note. Now moving on to next question number 22 done, right? Now 23. 23. Before I go, let us go for first 24. Again, interval problem. You may be thinking, what is a different notation? See here, there is one more notation for note. As a note, let us have. What is the note? Note is whenever we have got open interval A comma B, the other way of writing this is like this. This is something like no close interval, no close window. This is open window. End values are not taken. Okay. So now again same. A is the set of, okay, let us write in the usual form, open interval 2 comma 4, and B is close at 3 and 5 is open. So now if I just plot a number line 2 3 4 5 2 3 4 5 2 to 4 2 to 4. So start from 2 here and then 4, and this is our set A. Then 3 to 5. Okay, 3. This is closing at 3 and at 5 open. This is B. Now I want intersection. Intersection is what? Common. What is common between A and B? The common between A and B is this region. Close at 3. Nothing but 3 is taken. And here 4 is taken by, I repeat, 3 is taken by both set A and set B. But 4 is taken only by set B but not by A. Intersection means finding common element. So A intersection B will be, A intersection B will be close at 3, open at 4, which is same as, okay, it's already there here. Other thing is what? Close interval 3, 4 and open. So which is then option C. Similarly, you can think of A union B, A minus B and B minus A. Okay, now moving on to this question number 23. If x is a set of all number x where x is natural number, y is multiple of 2 into x where x is a natural number, and see this meaning 2 into x when x is a natural number means it's a multiple of 2, nothing but even number, and z is multiple of 5. Then what is x intersection y intersection z? Method number 1 will be write all this, then find the intersection. Method number 2, simple. What's x multiple here? 1. What's x multiple here? 2. What's x multiple here? 5. Take the LCM of this. Least common multiple. So here it's already 1, nothing to worry. 2 is there. 2 divide by 2. 2 ones are, then again 5. Divide by 5. So LCM of solution. LCM of 1, 2 and 5 is 10. So therefore x intersection y intersection z will be a multiple of 10 such that x is a natural number. So answer is option C. For union, we'll have x back. Correct? Note. If they ask x union, y union, z, be careful. This is what? Multiple of 2, 2, 4, 6, and move on. What is z? Multiple of 5, nothing but what? 5, 10, 15, moves on. And what is x? It is what? 1, 2, 3, all. So meaning to say that both y will be a subset of x and z will be also a subset of x. Therefore, x union, y union, z will be the universal set or this was a subset of this, so I can say x is a universal set, so it is x. Don't forget, if A is subset of B, then A union B is B itself. I hope this is clear. Okay, fine. Let us move on. See, simultaneously I'm trying to solve a problem as a note in place of taking a separate question. It just comes when we take the class now. That's what it's maybe called experience. Kindly make a note. Okay. Moving on to the next question. Question number 25. If A and B are two sets, then A union B is equal to A intersection B if and only if A is subset or equal to B, and option B is B subset or equal to A, and option C says both should be equal, and option D none of this. Let us understand the help of a Venn diagram. See, usual Venn diagram, if we see, this is universal set. This is set A, this is set B. This entire thing is A union B, correct? And only this region is A intersection B. So A intersection B is only the small part. Usually A intersection B is a subset of A union B. Now if at all it should be equal, it means what? Both should be same. If at all both, see, if at all the small part in this entire thing should be same, this can happen. A union B is equal to A intersection B can happen if and only if both are what? Equal sets. Both are equal set. Therefore option C is correct. I hope this point is clear. Coming to question number 26. We have been given X is a set containing -2, -1 up to 8, and let A be a set containing set of all integers when mod of x minus 2 is less or equal to 3. First solve this and then we have to find X intersection A. This is given rule method. Let us write in roster form. So we have an inequality here. Because of this itself, I thought you 5 different ways of writing different notation in inequalities under modulus. We know that modulus of x less or equal to A is same as minus A less or equal to x less or equal to A. So in place of A 3, in place of x minus 2, so this will become minus 3 less or equal to x minus 2 less or equal to 3. Minus 2 is there, to remove this, add 2 throughout. Whether you add or subtract, inequality will not change. So minus 3 plus 2 less or equal to x plus 2 minus 2 less or equal to 3 plus 2. Minus 2 plus 2 will get cancelled. Minus 3 plus 2 will be minus 1 less or equal to x less or equal to 3 plus 2 will be 5. I want only the integers between minus 1 to 5. Which are the integer between minus 1 to 5, including minus 1 and 5? That is minus 1, 0, 1, 2, 3, 4, 5. So now I want x intersection A. Therefore, x intersection A, see carefully, minus 1, 0. What's common between this? A and x. A is here and x is this. What is common between the both? Minus 1, 0, 1, 2, 3, 4, 5. Yeah, from here till here. It is common. So answer is minus 1, 0, 1, 2, 3, 4, 5. Minus 1, 0, 1, 2, 3, 4, 5. Option C, Chalu, is correct. Option C is correct. 0, 1, 2, 3, 4, 5. Yes. Now moving on to question number 27. Both we can either solve by using a problem chosen by you or by Venn diagram. I would like you to learn through Venn diagram. It will be very powerful approach. Which one of the following is equal? This one is equal to which one they are asking. if since there are two sets and in the question they have no set disjoint. See, when you go for Venn diagram on your own examples, number examples, in question, if they have not mentioned A and B are disjoint, if they have not mentioned this, you will not take disjoint set. You will take A intersection B to be non-empty until unless not stated. Okay. So here they are not stated. So I'm going to take A and B to have some common elements. So this is set A, this is set B. Now I want union of A. This A is the entire set. This, okay, let's shade whatever they want. Let us shade A. A is this. Okay. A intersection B. A intersection B. Intersection, as we know, this region is intersection. This also I want, so I will shade like this. See, this together solution. This together we got A itself. Okay, now we have to only bother about B minus A. So B minus A, what is B minus A? It is this region. This is B minus A. So ultimately, I have this all together. It is union. So all together will be what? A union B. So see, this is A. This is B minus A. Combined together, we get A union B. That is then option blue. Option blue. Now, as a note, what could have been the same problem if they have given like this? See, from the diagram again, A intersection B, nothing but this is A, this is A intersection B. So the common between A and this region will be what? A intersection B. The answer for this two. Then intersection B minus A. B minus A is this region. And A intersection B is this. So the common between these two is nothing but empty set. Okay. One problem we can frame like this, no? Now see this question. For all the sets, let's again take the Venn diagram for this solution. Okay. So here we have got set A, and here we have got a set B. A union B will be what? A union B will be this region. Oh, A union B, no, full. Yes, full. This entire thing is A union B. Then they are saying from that remove B. From that remove B. B is what? Black color. Circle. So if I remove this entire thing, I don't want. If I remove, then I will get only this region. What is this region? Only A, nothing but A minus B. A minus B, option blue. See, from Venn diagram, you can get the answer like this. No? Very fast, very quick you will get. I hope this is clear. So kindly make a note of this. Let's suppose the question was as a note. Let us suppose the question was A intersection B minus B. Then what is the answer? A intersection B. What is A intersection B? Common part. Minus B. From that remove B. B is what? This entire thing. From A, this also contains B. If I remove, what would the answer? It will be what? Think. A intersection B contains all the element common between A and B. From that remove B, I will not have anything left out. It will be empty set. You can verify yourself by taking a suitable example, such a way that A and B are not disjoint. Okay. Kindly make a note. Okay, dear students, next question. See, this type of question either you can go by Venn diagram or you can take your own example. For example, so take when I say own example, satisfying the condition of the question. They said A is subset of B. If I take an example where A is, let us say 1, 2, and B I will take such a, so I'll take 1, 2, and then I write 3, so that A is subset of B. Then what is A minus B? What is this? All the elements contain only in A but not in B. So 1, 1 gone, 2, 2 gone. Correct? No. So I'll get C. I write it again here. 1, 2 minus 1, 2, 3. So I can see 1, 1 gone, 2, 2 gone. Nothing is what? What we are getting? Empty set. Option E. From the Venn diagram also we can get C or the alternate. Draw Venn diagram such a way that obeys the condition A is subset of B. So if set A is this, set B should be containing A. Now when I'm saying that from this is here, right? I want to from A minus B, I want only A. I don't have only A because it is contained in B. If I remove this entire thing, nothing is present for A. So it's not empty set. Maybe you maybe not be able to understand this. So I have taken a example. Okay. Next question. If x and y are the two sets and x complement denotes x dash denotes x denote the complement of x, then x intersection x union y the whole complement. Again, for this I can take Venn diagram. It's no very difficult job. See, this is x and this is y. X union y the whole complement intersection x. X union y means both the circle. This is our x union y. This is our x union y. I want whole complement. Whole complement is what? I don't want this shaded region. Nothing but it is this. Other than both the circle. Other than both the circle. Now if I take common between the circle x and this, I mean to say, yeah, if I take the common between the circle x and this blue color shaded, do we have any common? Common do we have between this red of x and this? No, nothing common. Therefore, the answer for x intersection x union y the whole complement will be what? Empty. Answer is option chalu. Option C is correct. Here, before taking question number 31, I just want to discuss one concept on linear inequalities. So, linear inequalities separately, in place of doing it will be done, I will be taking here only linear inequalities, all the rules I try to understand. Let us suppose that I have got two real numbers, 3 and 4. Coming to inequality, we have got either whenever any expression contains less than, greater than, less or equal to, greater or equal to, we call it as inequality. Whenever the variable degree is 1, we call linear, and containing inequality we call linear inequality. For example, this is a linear inequality because variable is there, and degree is 1, so linear, and inequality is there, so linear inequality we say. Now here, if I try to go with this one example here, what could be the inequality between 3 and 4? It is less than. Now let us try to add one number. Let us understand all the rules under inequality. If I add any positive number, let us suppose 2. So 3 plus 2 and 4 plus 2. I am not writing what is the value between, means what is the inequality between them here. I am keeping empty box as it is. So 3 plus 2 is 5. And 4 plus 2 is 6, 5 is less than 6. Oh, whatever inequality we had, same inequality we got. So inequality will not change whenever you're going to add any numbers. What about add positive numbers here? So again, I'll take the same 3 and 4. If I add minus 2, nothing but here I added positive number. What if I add negative number? So 3 minus 2 and 4 minus 2. 3 minus 2 is 1, 4 minus 2 is 2. 1 is less than 2. Yeah, it was less than already. 3 less than 4, and now also less than itself. So I just kept the box as it is here. I didn't wrote anything there. So whenever you are going to add or subtract any real number, inequality will not change. It will remain same. That's what we have understood from here. Now, third example. If I say 3 less than 4, if I just multiply by a positive number, multiply by positive number 2. So I have taken throughout 2 minus 2 to one particular number I am taking and discussing all the concept. So if I multiply 3 into 2 here, then 4 into 2. 3 2s are 6, 4 2s are 8. 6 is less than 4. Sorry, 6 is less than 8. Yeah. Correct. So again the inequality remains the same. So whenever you are going to add or subtract any real number, no need to get problem. Second thought, inequality will never change. But when you multiply by positive, first we have got it to be what? Inequality will remain same. Now let us see, and see, when I say multiply by 2, it also means that if I divide by 2, I'll get here 3 by 2 nothing but 1.5 and 4 by 2 nothing but 2. So 1.5 is less than 2. That also inequality holds the same. Now the fourth example, 3 less than 4. If I multiply by a negative number, where the inequality will change or not, we have to see now. So now you see carefully, 3 into minus 2 and 4 into minus 2. 3 into minus 2 is right here, minus 6. 4 into minus 8, 4 into minus 2 is minus 8. Now, which inequality, who is larger, minus 6 or minus 8? Many will have a doubt in this. So for that, take a number bigger, larger than this, 10. Think in terms of rupees. From 10, if I give 6 rupees, if you have to give from 10 rupees, 6 rupees to someone else, remaining is 4. You are going to have, correct? Similarly, from 10 rupees, if you are going to give 8 rupees to others, remaining is what? 2. So was it 4 rupees and 2 rupees? 4 rupees is larger than 2 rupees, correct? So minus 6 is more than minus 8. Mean to say inequality got changed. Inequality will change only if you multiply by negative number or divide by a negative number. Otherwise, there won't be any change. Remember this. Inequality will remain same whenever you add or subtract any real number and whenever you multiply divide by a positive real number. Whereas inequality will change whenever you multiply by or divide by a negative numbers. Okay, kindly make a note. I'll take a problem with this. Okay, having understood that under inequality, whenever you add or subtract any real numbers, inequality will remain same. You can see less means less, less means less here. Whereas under multiplication and division, if you multiply by a positive real number, whatever the inequality we had, same inequality less is there. But when you divide or multiply by a negative real number, the inequality from less change to greater than. Same thing holds good for the remaining inequality. I repeat, same things hold good for the remaining inequalities. Now let us take the problem. The set A is set of all element x having the condition modulus of 2x plus 3 strictly less than 7. As I discussed today, that mod of x less than a is same as minus a less than x less than a. In place of x, we have 2x plus 3. In place of a, we have 7. So minus 7 less than 2x plus 3 less than 7. Okay. Now you see the option. In all the option, it is solved for, okay, here we have got x plus 5, then x, 3x and 2x. Here, see, there is no case of x plus 5 here. So I want x, solve for x. How to solve for x? First I have to remove 3. How to remove 3? Add minus 3. And when I'm adding negative number, so adding minus 3 throughout, so minus 7 minus 3 less than 2x plus 3 minus 3 less than 7 minus 3. Now you can see here, plus 3 minus 3 will get cancelled. Minus 7 and minus 3 will be minus 10 less than 2x less than 7 minus 3 is 4. Now check 2x, yeah, 2x is then option D, but here it is minus 13 and 4, but we have got minus 10 and 4, option D is out. Now coming to option B and C, x is there, get x. So how to get x from here? Divide by 2. If I divide by 2, 2 being positive, as you know, whenever you multiply, divide by a positive number, inequality will not change. Any positive real number, multiply and divide, inequality will not change. So what will get here? Minus 10 by 2 less than 2x by 2 less than 4 by 2. Recording, no? So now 2 1s are 2 5s are 2 and half will get cancelled. 2 1s are 2 2s are. Let's comment here. So what we have got? We have got minus 5 is less than x less than 2. Check it out. Coming to x, minus 5 to 2. See here x is there, minus 7 to 7 is there, and minus 3 to 7 is there. So both B and C out. Now here plus 5 should be given. Here x plus 5. Here also 5 I should have. So add 5. See, surely option A will be correct because B, C, D is out. But I want to understand how to get that. So how to know that I have to add 5? Because I want to get this expression. Here it is only x, but here I have got 5. X plus 5 I want, so I have got only x, so add 5. So minus 5 plus 5 less than x plus 5 less than 2 plus 5. Minus 5 plus 5 will be 0. Both will get cancelled. Less than x plus 5. Then 2 plus 5 will be 7. So we have got 0 to 7. 0 to 7 is there in option A. Option Alu. Okay, now let us move on to the next problem. if A and B are two disjoint sets, okay, they gave one condition, A and B are disjoint, nothing but the intersection between them is empty. So then B intersection A complement is, where A complement is complement of set A. So if I take Venn diagram now, I have to go with this condition that A and B should not have anything in common. So this is A and this is B. Now I want A complement intersection B. A is this. A complement will be other than the circle A. So I'm shading other than the circle A. That also contains B. Now you see carefully, since I want what? B intersection A complement. From the diagram, what is common between the circle B and the blue color? It is B only. So answer option blue. I hope this is clear. Common between the circle B and this blue color is, you can see a circle B and blue is common together. So set B is the correct answer. Next question number 33. In rule method, the null set is represented by which among the options? Coming to option C and D, these are roster form. They want which form? Rule form, due to which both the options are wrong. Because I want rule form. Now, set B says every element X is equal to itself. Then it is not a empty set. I'll have the entire set. For example, R, if I take, the entire R will be every number of set of real numbers is equal to itself. So the answer will be R itself, which is not an empty. But set of all number X which is not equal to itself. Which element is not equal to itself? Every element is equal to itself. Therefore, this will be an empty set in rows. I mean to say rule form. Okay? Kindly make a note. Okay, moving on to next problem, dear students. On this, I'll be taking some special cases. I mean, some problems. Set A has 3 elements. So, number of element in the set A is 3. And set B has 6 elements. So, 3 in A, and in B we have number of element is 6. Then minimum number of elements in A union B. See, minimum. Similarly discuss maximum. Then for A intersection B also discuss. Solution. I already wrote no solution. If at all I want minimum number, surely one set should be contained in other. One set should be contained in other. See this. If one set A is contained in B, then number of element in A union B minimum will be B only. So since A contains 3 elements and B contains 6 elements, number of element in A is lesser than B. So I have to surely take A is subset of B. Let us suppose that this was A, this was B. So A contains 6 elements and B contains 3 elements, then B is subset of A. Okay. So now minimum number of element will be number of element in A union B. Since A is subset of B, A union B will be B itself. And how many element B contains? 6. So option B is correct. Now let us suppose on this some note. In the see, instead of writing again one question, I have taken as a note, okay, to save some more time. Let us suppose that in place of minimum, they asked first part maximum number of elements in A union B. Maximum amount. In maximum, what should happen is A and B should be 2 disjoint sets. If they are disjoint, then only union of these two will have more and more number of element. So for maximum, A intersection B should be disjoint, due to which number of element in A union B will be number of element in A plus number of element in B. How many elements do we have in A? 3, B 6. So 3 plus 6 will be 9. A separate problem can be framed like this. Similarly, one more question. Here, it was spoken about union. Let us suppose we are talking about same. What could be the intersection wise? Minimum number of of elements in A intersection B will be how many? For minimum, there should not be anything common between A and B. It will be a disjoint set. For disjoint set, number of elements will be common will be 0. Point C. Maximum number of elements in A intersection B. As you can see in this problem, A is subset of B have taken because number of element in A is lesser than B. So if at all you want maximum number of element that is in A and B, nothing but common, surely A should be contained in B. Then it will be number of element in A if A is subset or equal to B. So in this particular case, okay, hence the minimum number of element is how many? B. A contains 3. So hence 3 will be maximum. I'm going to say maximum, not minimum. Maximum number of elements in A intersection B. Okay. Fine. I hope this is clear. Now this question. Let's just check. For maximum A and B should be A and B itself. For minimum it should be A should be contained in B. Fine. And for maximum, okay, fine. And intersection should be contained. Fine. Let the number of element in universal set is 700. Number of element in A is 200. Was it? Number of recording. Number of element B is 300 and intersection is 100. What will be number of element in A complement intersection B complement? Solution. Number of element in A complement intersection B complement. By using De Morgan's law, we can write this one as A union B the whole complement. And we also know that A complement is universal minus A. So whichever set is there inside the complement, that should be subtracted from universal. Inside the complement, we have A union B. So it is number of element in universal set minus number of element in A union B. Number of element in universal set is 700. Substitute. What is the formula of number of element in A union B? It is number of element in A plus number of element in B minus number of element in A intersection B. So number of element in A is 200, in B 300, and in common 100. So see, 300 minus 100 is 200, 200 plus 200 is 400, so 700 minus 400, what will be 7 minus 4? 3, so 300. So 300, so option C will be correct. Okay, option C will be correct. Number of element in A complement intersection B complement. Now, this question number 36 says, if AN is the set of first n primes, then this symbol stands for intersection. Let us understand the meaning of this. The meaning of this is when n is equal to 3, put here A3. This symbol is intersection. So intersection. Next, n is going till 10. So n is equal to 4. Next number. Again intersection. N equal to 5. Like this, I have to go till n is equal to 10. I hope this is clear. So what is the intersection of A3, A4, A5 up to A10? Where AN stands for set of first prime numbers. Now if I talk about solution A3. So first 3 prime numbers. Prime numbers are those which are greater than 1, divisible by 1 and itself. So 1 is not a prime number, 2, then 3, then 5. Stop. Why sir? 3 means first n prime numbers, n is there here. So since 3 is there, first 3 prime numbers. Now if I write 4, which are the first 4 prime numbers? 2, 3, 5, 7. If I write A5, which are the first 5 prime numbers? 2, 3, 5, 7. 9 is not a prime number. It is divided by 3 also, just an odd number. 11. Like these, I have to go till A10. Now what I want to say here is, observe from here. A3 is, not define all, observe from here. A3 is 2, 3, 5 is also contained here. So A3 is subset of A4. A4 is subset of A5. And like this, all are subset of A10. And we know that if A is subset of B, then A intersection B is A itself, the subset itself. So the intersection of the all is what? A3. What is A3? 2, 3, 5. 2, 3, 5 is there in option blue. Similarly, make a note as a note. What could be, if I have given union here, what could be union of, this is actually the answer of what? Intersection of AN running from 3 to 10. Similarly, in place of intersection, if I have union N running from 3 to 10, then it is A3, union A4, union A5 up to A10. What could be the answer? Don't forget, let's comment here. Don't forget, if A is subset of B, then A union B is the proper subset B. So since all are subset of A10, the union of all this is what? A10, the first prime numbers. Okay, the first prime numbers. That we can list out. Not a problem. But I want you to understand this. I hope this point is clear. Kindly make a note. Okay, dear students, moving on to the next two questions. Question number 37 says, two finite sets. Recording, no? Yeah. I repeat, two finite sets have M and N elements. So there are two sets which are finite. Let us suppose the set which are finite will take A and B. So set number of element in the set A is R, M in number. Number of element in the set B are N in number. Let us assume it. Means let us take the data. The number of elements is the power set of first set is 48 more than that of the power set of second set. Let us decode this. Number of elements in the power set of first set. What is power set? Collection of all the subsets. Okay. Collection of all the subsets. So they are saying number of subset in the first set. That is A I have taken. So number of subset formula is 2 to the power of number of element in that set. So as soon as they said number of element in power set, don't forget each element in the power set are what? Subsets of the given set. So whether they say number of element in the subset or number of number of subset of set A or power set, both are the same. Is, it said is 48. Is means equal 48. More means plus the power set of second set. Second set we have taken as B, so number of subset in second set B. Now I want to find A and B. Number of element A and B. So number of element in A we have assumed as M, 48 plus number of element in set B I have assumed as N, 2 power N. So if I transpose this, we'll get 2 power M minus 2 power N is equal to 48. Now we have to simplify. 48 is there. Simplify. Divide by small number, prime number. 2 2s are 4, 2 4s are 8. Getting the factors here. Then 2 1s are 2 2s are. Then 2 6s are. Then 2 3s are. So you have got 2 into 2 into 2 into 2, nothing but 2 power 4 into 3 we got. See the left hand side, both the bases are 2. So we want even right hand side also base to be 2. So now coming to 3, I can write as either 4 minus 1. So many ways are there. I will now can think as so why not 2 plus 1. Okay, I'll be preferring 4 minus 1. There is a reason why. Just see here. 4 is nothing but 2 square minus 1. Plus in, okay, now multiply now. Plus into plus plus 2 power 4 into 2 power 2 minus plus into minus minus 2 power 4 into 1 is 2 power 4. Now see, I have got minus here. Why? Because 4 minus 1. Since I have got minus here, why I'm preferring this? Why not this? Because here we have got plus, but here we want minus here. So now easily I can think of comparing 2 power m minus 2 power n. Bases are same, we can add the power. 2 power 4 plus 2 will be 6 minus 2 power 4. So 2 power m minus 2 power n. Now from here we can think of equating the things, equating the power. So in both the side we have got the same, bases also same, in between minus. Now you can equate the power. So in place of m we have 6, in place of n we have 4. So m is equal to 6 and n is equal to 4. So the answer m comma n should be here 6 comma 4. 6 comma 4 is there in option Chalu, option C. I hope this is clear. Okay, now let us move on to next. Question number 38 from the chapter 6. And don't forget our target is 55 plus. So I went with all the means. Okay, that's why it has gone so lengthy. Question number 38 says a survey shows 63% of the people watch a news channel, whereas 76% watch other channel. Watch other channel. If X% of the people watch both the channel, then you can see for the first one you got inequality. See, whenever it's a percentage problem, we are going to have complement, nothing but we are going to have universal set also. See, so since it's a survey problem, we can surely have universal set. Don't forget, A intersection B is a subset of A or B. Surely it should be a subset of both. And this is subset of A intersection B. I use the word comma here than or, because or you may feel that either it is or this or it's both. Okay, and then this two are subset of A union B. I mean to say A union B, and A union B subset of universal set. Don't forget this. Now they are saying no, that one set of people are going to watch news channel. So let us suppose that is A, and that is 63 in number, and another channel B I will take, and that is 76%, 76 in number, and total number of people in that particular area is 100. Okay, let's assume that, because how can I assume so? Because it's a percentage problem, so it is 100%, so 100. So we are taking all in terms of numbers here. Now we know that number of element in A union B is equal to number of element in A plus number of element in B minus number of element in A intersection B. So here what is common we have to find. So let us assume that number of element, nothing but number of people watching both the channels are X in number. So A union B, we will keep as it is. Now just see it, n of A is 63, n of B is 76 minus n of A intersection B, and I will just write here n of A union B. And now if I add this, how much we are going to get? 9, 13, n of A intersection B, and this, don't forget, A union B subset of universal set. So it is less or equal to number of element in universal, and number of element universal is what? 100. So less or equal to 100. So if I transpose from here, minus number of element in A intersection B is less or equal to 100 minus 139. So less or equal to minus 39. Then minus number of element A intersection B. Negative is there. Multiply by negative. Now comes inequality. Recall, inequality will change, reverse whenever you multiply by negative number. So multiply by minus 1. So I'll have n of A intersection B greater than or equal to 39. Number of element in A intersection B, common element, or number of people watching both the channels are X. So X is greater than or equal to 39. Okay, this is one relation, one such condition if I have got universal. And here when we have went, no, we are saying that there is nothing like both are not subset of, need not be a subset of each other here in this case. So now if I talk with respect to since number of element in A is 63 and number of element, nothing but people watching the news in one channel is 63, other is 76, 6, I can also have that number of people watching both can be common. And common such a way that this is subset of this. Here we have not said the subset of each other, just common is there. So this can be less or equal to number of the minimum. Minimum of both is what? N of A because 63. So it can be less or equal to 63. And what is this? X. So combining both 1 and 2 on combining. What we are going to get on combining, we will get, see this, that's again this one still more better. X is greater than or equal to 36. The same like 2 is okay, 5 is more than 2. 5 is more than 2 same as 2 is less than 5. Correct? So similarly, this is same as 39 is less or equal to x. This is our equation or inequality 1. So combining 1 and 2, what we are going to have, 39 is less or equal to x and x is less or equal to 63. X is less or equal to 63. Yes, this will be the people who are watching the channel. Common both A and B between 39% to 63%. That is their option C. So Chalu is correct. Kindly make a note of this. Let us move on to next question. And I've taken some question here which has been asked in previous year Kcet. This question from 2022. Question says, question number 39. If A is equal to 1, 2, 3 up to 10, so it contains, set A contains first 10 natural numbers, then the number of subsets of A, but one condition, containing only odd numbers. I want only those number of subset which contains odd numbers. Now from here, solution, let us try to take one subset B of set A which contains only what? Odd numbers. Which are the odd numbers? Any number which are not divisible by 2 is known as odd numbers. And 1 to 10, the odd numbers are 1, 3, 5, 7, 9. Now I want only those subsets, and this is a subset of A. But I want all those subsets containing these odd numbers. So we know that number of subsets formula is, since I want for this set, okay, containing only odd, so the formula will be 2 to the power of number of element in B. But don't forget, this will also contain an empty set. But they want only those set containing what? Odd numbers. So we don't want empty. So minus 1. This minus 1 is for what? Empty set. I want to remove empty set. So is equal to now to number of element in B. How many are there? 5. 1, 2, 3, 4, 5. Minus 1. 2 power 5 will be 32. Minus 1 will be 31. 31 is in option A. Option A is correct. See how they have asked the question. Dear students, now let us move on to the last question, question number 40, which has come in the year 2025, that is last year. Question says, if A is set of all the element x such that x is an x is an integer and x square minus 9 equal to 0. B set of all element x such that x is an natural number and 2 is less or equal to x less than 5. C is set of all element x. X is a prime number less or equal to 4. Then we have to find B minus C union A is, and options are given. Now let us first rewrite set A, B, C in roster form. Present it is in rule form. So coming to the solution of this, A is an integer having x as this quadratic solution. So coming to set A, I have to find the roots. The roots of this are the elements of set A. So if I simplify quadratic equation, x square is equal to 9, x is equal to plus or minus 3. Therefore, the element of set A is plus 3 and minus 3. So minus 3 and plus 3 in order I have written. What is B? Set of all the natural numbers such that 2 is less or equal to x less than 5. In this interval, I have to take only natural number where 2 is taken and 5 is not taken. All the natural number obeying this. So 2, 3, 4. 5 is not taken because we have strictly less than. There is no equality here. Next, C is what? Set of all prime numbers less or equal to 4. Which are those prime numbers? Define prime number. Any number which is greater than 1 divisible by 1 and itself. Only these two conditions should happen. Should satisfy. So now in this, the prime numbers less or equal to 4 will be 2 and 3, because both 2 and 3 are divisible by 1 and 2 is divisible by itself, that is 2. 3 is divisible by itself, that is 3, and no other number can divide this other than 1 and itself. So it's a prime number, and don't forget, always prime numbers are larger than 1. 1 and 0 are neither prime number nor composite. Okay. Now, having this, now we want to find first B minus C, then union A we have to take. B minus C, recall, B minus C means all the element only contained in B but not in C. So B 2, 3, 4, let us substitute first. Then minus C is 2 and 3. So now if we simplify, yeah, 2, 2, 1, 3, just think as a subtraction. And I want only the element present in what? B but not in C. So remaining element is 4. This is B minus C. Now we want B minus C union A. So B minus C union A. What is B minus C? 4. And what is union A? A is plus 3 minus 3. Now, as we know, when we talk about union, writing common and uncommon element only once. So we are going to have minus 3 plus 3, 4. This will be the solution for this problem for the set B minus C union A. That is then option minus 3 plus 3, 4, option A. Kindly make a note. Dear students, with this we come to an end to the chapter 6 of Kcet. Make sure, give you 100%, be dedicated. You have to work really hard to achieve this 55 plus. Okay, so God bless you all, and make sure, try to make the notes as in how the class is, the video lecture is going on. Okay, all the very best. God bless you all. And lastly, do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.